continue with example 3 in this lesson. Simplify a rational expression. So, what is the simplified form of the rational expression? What is the domain for which the identity between the two expressions is valid? So if you see this rational expression where we have two polynomials for the numerator and the denominator, we can simplify them by factoring them out and see if we can cancel anything out, right? So simplified form of a rational expression has no common factors other than 1 in the numerator and the denominator. It's the same for numerical fractions. So for example, you have 4 over 6. Do they have the same factor? Yes, 2 times 2 over 2 times 3 are factors for 4 and 6. You have to cancel out any same factors because 2 divided by 2 is 1, and you could do that, right? So that would be equal to 2 over 3. So we'll do the same thing for rational expressions where we can factor out the polynomials and see if we have any other any common factors, right? So if we factor this out, 4 minus x squared, we could factor it out to 2 minus x times 2 plus x over x squared plus 3x minus 10 would be factored out to x minus 2 and x plus 5, right? And then we see some common factors here. Although the orders are flipped by commutative property, you can say that x minus 2 would be the same as negative x minus 2 parentheses. So then you can factor these factors, common factors out, and you have a negative instead, and then you have negative x plus 2 over x plus 5, but then this is not the original form, right? The original form is this. So the original form, which before you simplified, you have all these factors, so your domain is going to still stay the same with the factors you originally have. So your domain is all real numbers except negative 5 and positive 2, which are our zeros for the denominator, right? So the simplified form would be negative x plus 2 over x plus 5, and they're equivalent except that it works for all real numbers except 2 and negative 5. So your simplified expression would have would not show you the limited 0 for the canceled factor, right? X equals 2 would not be limited if you just look at the simplified expression, but remember that your original expression had a restriction there. So you have to make sure that the simplified expression only works for all real numbers except 2 and negative 5 that were already the restricted domain in the original rational expression. Okay, so your final answer shouldn't just be the expression. You have to make sure you write this for all real numbers except blank, blank, blank. Okay, so let's do try number 2, A and B. Simplify this expression and state the domain. Pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Let's check the answer for 2a. So I'm going to write 2a over here. You have x squared plus 2x plus 1 all over x cubed minus 2x squared minus 3x. So factor each polynomials out. On top, you can use x plus 1. Sum of the differences, right? X plus 1 squared all over. You can factor the x out, and then you have x squared minus 2x minus 3. And so if you factor that polynomial out, you get x minus 3 times x plus 1. And then x plus 1, we have a common factor. So then we're going to cross this out and that out. And finally, we have x plus 1 over x times x minus 3, but don't forget to state the domain for all x except what? Your original zeros were 0, positive 3 and negative 1. So all x except 0, negative 1, and positive 3. Okay, let's look at 2b. You have x cubed plus 4x squared minus x minus 4 all over x squared plus 3x minus 4. And so factor this out. On top, you can factor by grouping. So group the first two terms and the other two terms. And then you can factor the first two terms out with the common factor x squared. Then you have x plus 4. And then you have minus parentheses x plus 4. And so if you distribute the negative out, you'll get negative x minus 4, right? So you can factor the negative out on the second on the third and fourth terms here. And you see the same term x plus 4. We're going to factor that out as well, but let's look at the denominator first. We can factor this easily out with the factors x plus 4 and x minus 1, right? And we're done with the denominator. So on top, we're going to factor one more time, x plus 4, and then we get x squared minus 1. And so we already have the factored form in the denominator, so just write that down. And then you already see the same factor here, so cross x plus 4 out. And x squared minus 1 could be factored more using difference of squares, right? So this one is actually x plus 1 times x minus 1. And so, oh wait, so sorry. This should be negative 1, right? Yeah, that's a typo. So that's negative 1. And so x minus 1 in the denominator, you have the common factor, cross that out. You have x plus 1 as a simplified expression, but you need to state the domain for all x except what's our original restriction. If you look at this, our original expression is positive 1 for 0 and then negative 4, right? So all x except 1 and negative 4. Okay, good. So these are our final answers. Please check your answers and see if you got it right. If you did, good job. That was example 2. And try number 2. Well, 3. Multiply rational expressions. Part A, what is the product of 2xy over z and 3x squared over 4yz? So we're going to start multiplying rational expressions. It has the same properties as the numerical ones, right? So whatever like terms you can multiply, then multiply and then combine them. Okay, so here 2xy is in the numerator, 3x squared is in the numerator, so you can multiply the numerators, and then whatever is in the denominator, you multiply them together, and whatever factors that you see, and the same factors you see in the numerator and the denominator, you cancel them out because the same factors divided together would equal to 1. So then you can cancel them out in fractions. So multiply 2 and 3. But we do have the same factor here for 4, right? So if you factor out completely, you will have 2 canceled out, then you have 3 over 2. Then you have y canceled out because there's 1y and 1y for each numerator and denominator. So you can cancel them out. You will have 3x cubed over 2z squared. If you simplify it. So the product is 3x cubed over 2z squared. So here, make sure you simplify your product when you're finding the product of these rational expressions. And make sure if there are any restrictions, list them. So the product is 3x cubed over 2z squared for all real numbers except when y is equal to 0 and z is equal to 0. So y cannot be 0, z cannot be 0. And it's not just from looking at your simplified product. You have to look at your original product. Z cannot be 0 here. Y cannot be 0 here. And this, because Z cannot be 0, you don't have to repeat the same thing here. Okay? So that's a basic example. Let's look at another example that's more complicated in the next page. Part B. What is the simplified form of 5x over x plus 3 times x squared plus x minus 6 over x squared plus 2x plus 1 times x squared plus x over 5x minus 10? Well, you do the same thing. You see if you can factor out all possible polynomials if you have any. So x squared plus x minus 6 could be factored out as x plus 3 times x minus 2. And then x squared plus x could be factored out by the greatest common factor x, and you have x plus 1. And then on the denominator, you do the same thing, and then see all your factors here. From here, you should already list out your restrictions. Your denominator cannot be 0, so x cannot be. So all real numbers except when x is equal to -3, -1, and +2, right? So these are your restrictions at the end, as you can see here. And then you can now cancel them out, x plus 3, and then x plus 1, x plus 1, x minus 2, x minus 2. And then, oh, yeah, this one you still have x plus 1 because that's a square. And then you can cancel out 5 as well. So you have x times x over x plus 1. And so x squared over x plus 1 for all x that's not equal to -3, -1, or 2 would be your final answer. So let's do try number 3. Find the simplified form of each product and give the domain, of course, with your product. So simplify, and before you even cancel out and simplify, please look at the domain and find the restriction so that you don't forget it later. So pause the video and come back when you're ready for answers. Okay, are you ready? Let's look at 3a. So 3a, let me write it here. You have x squared minus 16 over 9 minus x times x squared plus x minus 90 over x squared plus 14x plus 40. So you're going to factor out as much as possible. So the first fraction, you can factor out using the difference of squares, x plus 4 times x minus 4. And then 9 minus x, you can factor out negative so that it's easier to see common factors. So and using commutative property, you can write x first as your first term. So negative parentheses x minus 9 would be the same as 9 minus x. And then factor out the second rational expression. You have x plus 10 times x minus 9. That will equal to that polynomial. And then on the bottom, 40, the factors of 40. Ooh, there are many factors of 40. But you have to add them to get 14. So the only pair that would work is x plus 10 and x plus 4, right? 10 times 4, 40, 10 plus 4, 14. Good. And now we see common factors. But before we do that, let's write the restrictions. So x cannot be, the zeros of x are 9, and then we have -10, and we have -4. So these are the zeros which cannot be the values for x. And then now we can cancel out x plus 10, x plus 10, x minus 9, x minus 9. Remember, we have a negative here that we factored out. X plus 4, x plus 4. So really, at the end, we only have the negative and the x minus 4. So we'll just write negative parentheses x minus 4. Don't forget to write the parentheses, otherwise you'll have a different answer. Negative parentheses x minus 4 is equivalent to negative x plus 4. So if you just get rid of the parentheses, you'll have a different expression because -4 will be changed, right? Okay, so this is not all. You have to write the domain for all x except what? We already found these. So except -10, -4, and 9. Good. That wasn't too hard. So you just need to factor out correctly. Make sure you factor out negative when you want to change your order for your binomials that look like this, and then make sure you write the restrictions for domain from your expression before you simplify. Okay, let's continue checking the last one, 3b. You have x plus 3 over 4x times 3x minus 18, 6x plus 18 times x squared over 4x plus 12. So factor them out. The first fraction is already factored out, so I'm not going to touch that. 3x minus 18, you can just factor out the greatest common factor of 3, 6. And then this one as well, you factor out greatest common factor 6. Not too hard. And then you have x times x. You can just write x squared, but I just want to cancel them out easily, so 4 times x plus 3 would be the greatest common factor for 4x plus 12. And now we're done factoring everything. So let's find the restriction. The zeros would be 0, and then -3, and -3, right? So 0, just 0 and -3. And then now let's cancel them out. X plus 3, and then 3 and 3 from 6. I didn't factor out 6. Do we have more? Oh, x and 1x over here. I think that's it. So we have x times x minus 6 in the numerator. And then we have 32. 4 times 2 times 4 is 32 times x plus 3 in the denominator. And don't forget to write your domain for all x except 0 and -3. Okay, so those are the answers for try number 3, A and B. Please check your answers and see if you got it correct. If you did, great job. We'll continue with the next example in the next video.